All right, now section 9.2. So we're going to talk about circles. We're actually going to chapter 10, but first we're going to introduce with section 9.2. So this is just a little intro to circles. Pretty easy. Let's go back to your grammar school days and remind ourselves of the formula for the circumference and the area of a circle. So formulas, we have circumference. Keep in mind, circumference means you're going around the circle. If you were a little bug and you were going to walk around the circle, how far would you go? So circumference is pi d, where d is the diameter. A diameter is made up of 2 radii, so we could also write this as 2 pi r. 2 and r make up a d. So those are formulas for circumference. We also need to remember the formula for area. Area is equal to pi r squared. And these two formulas look pretty similar, so keep in mind that a circumference is walking, so that's just one dimension. You can only walk in a line, right? You can only go forwards and backwards. Area is 2-dimensional, so that's why it has the squared, is for the square units. And that's why this r has a first power, because you're just walking in 1 dimension. Okay, so we need to talk about a circle a little bit. We have a circle with a center, and the circle has an infinite number of points on it. Let's just look at these two. The part of the circle, or the part of the circumference rather, that is in between C and D is called an arc. So this is arc CD. Or another way of representing it is CD with a little arc over the top. How many degrees are inside of a circle? If you were going to turn all the way around, you go 360 degrees. So each arc is made up of some portion of the 360 degrees. It's a distance, but it's also a portion of the 360 degrees. So you can find the length of an arc by knowing the portion of the circle that you are going to use. So let's talk about the arc length. The arc length. So let's say that we've got a circle. Again, here we go, here's a circle. And let's put them on the coordinate plane. And we'll say that this point here is over 6 up 0, and this point is over 0 up 6. And we'll call that A, and we'll call that one B. So the arc length from A to B's arc length, is a portion of the entire circumference. So the whole circumference is going to be pi d, or 2 pi r. Let's think about how big is the radius. If you're at the origin in the center, a radius goes over 6. So your r is equal to 6. So your circumference equals 2 pi times 6, or 12 pi. Don't use 3.14 for pi. That really makes me crazy because it's imprecise. It's an estimate of pi. We'll use just the symbol pi. It makes life easier too, right? We don't have to deal with decimals and multiplication with decimals. All right, so 12 pi is the entire circumference, but we just want this part from A to B. Take a look at this circle. It's been broken into quarters, right? If there are 360 degrees, each one gets 90 degrees, so 90 out of 360 better be 1/4, right? So we want this ratio of the circumference. We want a quarter of the circumference. So 1/4 times 12 pi, which is 3 pi. So to find arc length, maybe make yourself a little note, a summary. To find arc length, you need the circumference and the portion of the circle that you are working with. You can also find the area of a piece of the circle pie. So let's look at this again. We'll talk about the same one from A to B, 0, 6, 6, 0, A to B. Now I want this portion of the pie. Well, there's a fancy name for the portion of the pie. It's called the sector. It's the sector of a circle, and it's bound on either side by radii. And then it's also bound here by the circumference. So the piece of pie is called a sector. A sector is bound by 2 radii and the circumference. So a sector is 2-dimensional, right? We're not walking in a straight line. We're looking for the area of something. So there's our 2 dimensions. Same idea though. Let's find the area of the entire circle. So the area equals pi times the radius squared. We already said that r equals 6, so 6 squared. So our area is 36 pi. But we don't want the whole circle, we just want this sector. So let's figure out what portion of the circle are we talking about? What ratio of the circle do we want? Well, remember, this is 90 degrees. So 90 out of 360 is 1/4. So we only want 1/4 of the entire circle. So 1/4 times 36 pi. So 9 pi is the area of the sector. So it's 9 pi units squared. Right? So that squared matches with that squared. Easy peasy? I think so. Let's talk about another, I'll leave this here, another part of a circle. So here's our circle. We're going to draw an angle inside of the circle. The vertex of the angle is on the circle. So it's not floating inside, it's actually the vertex is on the circle. So we drew, or we scribed the angle in the circle. So this is called an inscribed angle. And we'll call it ABC. So angle ABC is inscribed. This line here, BC, and the line AB are called chords. Chords. They are lines that go through the circle. Their endpoints are on the circle. So AB, the endpoints of AB are on the circle. The endpoints of BC are on the circle. So those are called chords. So we have a little vocabulary, inscribed angle and chord. All right, let's do a couple of other examples, but we're pretty much done. So let's talk about finding the, let's take a look at this circle here. We've got a circle. Let's put them on the coordinate plane centered at the origin. That always makes life easier. Now we're going to draw a triangle inside. We're going to inscribe a triangle. Do you see it? There's a triangle right there. Or you could just say it's an inscribed angle, right? We already had this line, this axis here, so we can draw the triangle, or pardon me, the angle. And we'll say that this coordinate is the coordinate -10, 0. So this one is 10, 0. This coordinate up here is 6, 8. And we'll call this point I, this is N, this is S. All right, so we want to find out or determine if this is a right triangle or not. I'm going to tell you a little secret. This is actually a chapter 10 topic, but I'll tell it to you now. An inscribed angle, let me go back to this for a second. The inscribed angle is equal to half of the arc. So the inscribed angle ABC is equal to half of the arc AC. This is called the intercepted arc. So this AC is equal to, half of AC is equal to AB. So go back to our triangle. Look at this angle here. What arc does it intercept? IS. Well, what do you notice about IS? That's half of the circle, isn't it? What's half of 360? Pardon me, what's half of 180? There we go, half of a circle is 180. So this angle here is half of the 180, so it is 90. So that's what makes this a right triangle. All right, so we found angle INS equals 90 degrees. Let's find the slopes. Let's find the slopes of IN and NS. So our slopes. Remember the rise over run. We'll do IN first. Rise over run, so the change in y, I've got 8 minus 0 over 6 minus a negative 10, which is 8 over 16, or 1/2. And then we'll find the slope of NS. So 8 minus 0 again, over 6 minus 10. So that's 8 over negative 4, or a negative 2. Hey, what do you notice about these slopes? They are opposite reciprocals, which means they are perpendicular. Well, isn't that supported with what we already know, that it's a right triangle? These lines, of course, are perpendicular. So there you go. It all makes sense when you put it together. All right, last thing we'll talk about are reflections. Now remember, if that went too fast, you can pause or stop, go back and listen to that last part. That's the beauty of this technology. Okay, so we've got a coordinate plane. And let's put this point here, H. And we'll say that H is at the point 49, is located at 49. And we are going to reflect across the y-axis. So H goes across the y-axis. Where is its new point? Imagine folding the paper along the y-axis. So H gets put over on this side. Where will it be located over here? Well, it doesn't look like the y value changes. It looks like it's gone up the same amount. So we know we're going to have something 9. The x value, while the distance is still the same from the x-axis, it's just going the other direction. So it's at negative 4. There you go. I think there's a couple questions in your homework that ask about reflections, but that's how you do them. Pretty simple and straightforward. All right, I think that's it for 9-2. Any questions that you have on the homework, make sure you put them in the stream and I'll get to them and try and do a little video for you answering those questions. Have a great day.